Hello everyone, welcome to Science Friday, where we talk about electronics. But in order to understand electronics, we need to understand electricity. What is electricity? Well, that's a tough question. Let's start with what we do know. If electricity is in our phones and our lights, it even lets you watch this video right now. But it even makes you. Electricity runs from the synapses in your brain, from one synapse to the other. But that's what makes your brain work. But we still are nowhere to answering the question. What is electricity? Well, to be completely honest, no one really knows. All we have are abstract representations of electricity. But we do know how it works and what it can do for us. Electricity is defined as a flow of electric charge. Such a simple answer, but it raises so many questions. Where does it come from? What does it do? How can it do things for us? That's what I'm here for. But to understand these things, we need to go atomic. First off, atoms are really, 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 really small. Did I mention it's really small? Because they are. 1 grain of sand has more atoms than the stars in the known universe. This is hard to comprehend. Even in just 1 penny, if it were to be made completely out of copper, it would have 32 sextillion atoms. That's a 32 followed by 21 zeros. That's hard to comprehend. That's really incredibly hard to comprehend. But I found this website. It's called The Scale of the Universe. Check it out. Atoms are the most fundamental building block of the universe. But in order to understand electricity, we need to go even further down. We need to go subatomic. This is the level where we can see the different parts of the atom. Now, I am not going to explain all the specifics of atoms, because that is for a science class. No, I am here for a short amount of time to explain electricity to you guys. I don't have an entire lecture time for atoms. So the parts of the atom: protons, neutrons, and electrons. Protons are positive, neutrons are neutral, electrons are negative. Electrons go around the nucleus of the atom. The nucleus of the atom is made up of protons and neutrons. But for right now, we are concerned about the outermost electrons, or the valence electrons. These are what we use for electricity. We rip the electrons from the atoms, and that allows us to make charge. Oh, speaking of charge, remember the definition of charge earlier in this video? It's the flow of electric charge. Charge is quite similar to matter. It's measurable. Just like you can measure the mass of something, you can also measure a charge. However, there are only 2 states of charge: positive and negative. Now, it's not that hard to remember the charges of the different parts of the atom. Protons, positive. Electrons, negative. And the charge of these is quite important. It allows us to exert a force on them. An electrostatic force. The electrostatic force simply says opposites attract, similar repel. Remind you of anything? Magnets. The electrostatic force is the exact same thing that drives magnets. In fact, electricity is very closely intertwined with magnets. More on that later. But to use this electrostatic force to our advantage, we need wires. Now think of a copper wire, all with atoms in a row, all with valence electrons. And we rip 1 valence electron from 1 atom. And to fill that valence electron, another valence electron from the last one fills in that place, and so on down the chain. And you may be wondering, why do all atoms not do this? Why can't I run a current through my carpet? Well, some atoms conduct electricity much better. And by that, I mean they shared their valence electrons much easier than some others. And speaking of carpets, there's also another type of electricity: static electricity. If you have never encountered static electricity, well, it's nearly impossible that you've never encountered static electricity by now in your life. But if you are not familiar with static electricity, just rub your feet around on a carpet, and then just walk up to a metal object, or just go shock your friend. That's static electricity. Static electricity happens because there is a negative charge on one side of an insulator and a positive charge on the other side of an insulator. And if the difference becomes great enough, there will be a spark, even through the best insulators. One of the most extreme cases of this is lightning. We've all seen it. The way static electricity works is handy in some situations. It is what lets your touchscreens work. Touchscreens also need current electricity to work as well. In order for electricity to flow, we need a closed loop of conductive material. The only rule to this is that there cannot be any insulating gaps in this loop. But how do we get them to flow in the first place? The answer? An electric field. Well, what is a field? Well, it's a tool that we use to model physical interactions which don't have any physical contact. We cannot see these fields, but they do have a very real effect. We all have experienced one field in particular, gravity, specifically Earth's. This field can be modeled by having a set of arrows pointing in on the Earth. And the strength of that arrow is based on how far away you are from it. The closer, the stronger. The farther, the weaker. Gravitational fields and electric fields are very similar, but there is a difference. Gravitational fields exert force on objects of mass, but electric fields exert force on objects of charge. Now we come back to protons and electrons. Protons exert a force on electrons. Protons exert a force that goes outward from it, and electrons a force that goes inward. This makes an electric field, or what we more commonly refer to it as a magnetic field. Well, since electrons are negative, they will flow away from the other electrons into the positive protons. Well, we can move charges, but how does it actually do stuff? It's all about kinetic and potential energy. But to understand these two things, we need to understand energy in general first. Energy is the ability to do things. Energy is the ability to do work on something else, which means moving an object some distance. And of all the energy that's out there, there are only two kinds, kinetic and potential. When something is moving, it has kinetic energy. The amount of kinetic energy depends on its mass and its speed. However, potential energy is stored energy, and it has stored that energy when it is at rest. Potential energy is measured by the amount of work it could do if it were to be set into motion. So when it goes from rest to moving, it transforms its potential energy to kinetic energy. To help understand this, let's go back to our gravity example. Say we have a bowling ball and a basketball at the top of the Eiffel Tower. They both have the same heights, but they both have different amounts of potential energy. Due to how massive the bowling ball is, it will have more kinetic energy than the basketball. That is why it will also have more potential energy. As they go down, they are converting their potential energy into kinetic energy. And when they reach the bottom, all of their potential energy has converted into all of its kinetic energy. Now when the bowling ball hits the concrete, it will transfer all of its kinetic energy from it into the concrete. It will leave a crack, maybe even a dent, in the concrete. But the basketball, since that has less kinetic energy, it won't do as much. It'll only leave maybe just a little crack. But that's not the only thing they do to the concrete. They also heat it up and make a bit of a sound. It's the same for electrons. Putting a free electron near the other electrons and far from the protons, it will make the electron fly out from the electrons into the protons. Same as our gravity example. But in order to put the electron near the other electrons, you have to do work to put it there. You have to put the exact same amount of energy into it as you will get out. This is important for understanding measures of electricity. We come to electric potential, which is not the same as electric potential energy. Electric potential is the amount of electric potential energy divided by the amount of charge at any specific point in the field. So instead of having to say electric potential every time, we just decide to call it a volt. In any field, there are two spots where there is the most amount of electric potential and the least amount of electric potential. In our case, using electrons, the point of the most amount of potential energy is near the electrons, and lowest near the protons. So voltage is the difference between those 2 points. That is telling us with how much force it will push that electron. We have now acquired all the knowledge we need for understanding electricity. So let's take a battery and a wire. At the negative end of the battery, we have a lot of excess electrons, and at the positive end, we have many protons. There is a very high difference in potential energy in this battery. or a high amount of voltage. So if we hook up the wire to both ends of the battery, the electrons in the wire will be pulled from the wire all the way to the negative end to the positive end. Well, now you know how electricity flows. I would very kindly appreciate it if you let me know how I did and how I may be able to make this better. It would really make a lot to me, and so I can help you guys learn better. Well, I'd like to thank everyone for watching, and see you next time.